Hello and welcome to The Network Professor, a series of podcasts hosted by me, Glyn Jones, Product Manager at Hughes Europe. Hello and welcome to the 5th episode in the series of podcasts in brief, brought to you by me, Glyn Jones, Product Manager at Hughes Europe. If you have listened to some of my earlier podcasts, you'll know that I've been in the networking industry for many years now. In fact, 38 plus years and counting. But my next comment will really show my age. If I look back to what wide area networks were like when I first started out in the industry, they were very different from what they are today. The internet was still very much in its infancy, and the World Wide Web didn't exist. I know, no World Wide Web. How did we cope? I remember building a network in Wales, and the highest bandwidth we could get out to Swansea and beyond was 9.6 kilobits per second. Yes, that is kilobits per second, not even megabits per second. And for those who don't know Wales well, Swansea is the second largest city in Wales. So, looking back over the last 40 years, what has changed in wide area networking? Well, the amount of bandwidth available has certainly changed. Though even now, where hundreds if not thousands of megabits is the norm, there are remote places where you might only get 1 megabits of terrestrial bandwidth. In reality though, what has really changed from a wide area network perspective? At the end of the day, the fundamental requirements has not changed at all, and that is how to efficiently get information between point A and point B. Designing a WAN has always been about how can we connect point A to point B, though it is now often point A to B to C to D and any variation of them. WANs often used to radiate out from a central site, which we'll call site A. You would then add site B and connect them via a circuit. You needed to add another site, C, and this would connect back to site A, and so on. Each time you needed another site, you would add another circuit, all nice and linear. This was known as a star network. Then people wanted to be able to send traffic directly between all sites without having to send traffic via the central site. So they started linking all sites together, creating what was known as a mesh network. The problem with a mesh network is that as the number of sites grow, the number of circuits required grow exponentially. For 2 sites you need 1 circuit, for 3 sites you need 3 circuits, for 4 sites you need 6 circuits, for 5 sites you need 10 circuits, and so on and so on. Even just 32 sites would require 496 circuits to connect them all together in a full mesh. So mesh networks were a salesperson's dream, but for network managers they were a nightmare to manage and run. And as for the cost of such a design, I'll just go with they were not cheap. To help provide this any-to-any connectivity, the giants of the networking world developed MPLS, which took the concept of the mesh network and collapsed the mesh network into the service provider's core network. And then your sites connected into the core with 1 circuit, or 2 if you wanted resilience. This dramatically reduced the number of circuits required. A 32-site network only needed 64 circuits, assuming you wanted resilience. Whilst the number of circuits reduced, the complexity of the configuration increased, and for most businesses you became reliant on your MPLS network provider. As with any technology, time does not stand still. As the end user requirements change, the way we have to design networks changes to follow suit. Whilst MPLS is still around, with the growth of cloud, the need for any site connectivity and backhauling to a data center is diminishing, and the need to be able to connect directly to the internet, cloud services, as well as customer-owned services is increasing. With these changes in user requirements, the next big change in WAN design was the move from MPLS to SDWAN. When SDWAN made its debut, it was like a superhero in the networking world. But what is SDWAN and how has it impacted modern network infrastructure? In its early days, people loved it for its simplified network management and the way it allowed you to manage traffic to improve availability and performance. But in this fast-paced world of modern network infrastructure, where new technologies like SASE are stepping onto the scene, you might wonder if SD-WAN is still the champion it once was, or if it's slowly fading into the background like its predecessor MPLS. So let's explore the evolution of modern network infrastructure and where SD-WAN now stands, answering questions such as, what is SD-WAN, and why did it become the go-to solution that left MPLS by the wayside? How has SD-WAN influenced new solutions in network infrastructure technology? And finally, does SD-WAN still have a place in today's network landscape, or will it soon be replaced and just become a feature in the history of digital technology? Let's look at the journey from MPLS to SD-WAN. Back in the late 1990s, everyone was talking about MPLS, which stands for Multi-Protocol Label Switching, the network solution that promised faster and more reliable network performance through efficient traffic routing. But as the digital world kept evolving and businesses started moving more of their stuff to the cloud, cracks in the capabilities of MPLS began to appear. Firstly, it struggled with latency issues, as all the traffic had to go through a central hub before reaching its destination. Not exactly the most efficient way to do things, but that's not all. MPLS also heavily relied on specific service providers. This often imposed geographical limitations. For big, spread out businesses that wanted to share data between different locations, MPLS struggled to fulfill their needs. It was time for a fresh, flexible solution that could handle the complexity of cloud traffic, keep the performance top-notch, and be super agile for multi-site organizations. And it was the next-gen wonder SD-WAN technology that stepped up to tackle these challenges. So, what is SD-WAN, and what benefits does it offer over MPLS? Firstly, let's break down what SD-WAN is all about and why it's got some serious perks compared to MPLS. SD-WAN stands for Software Defined Wide Area Network. It may not be the catchiest of terms, but the benefits it offers certainly caught everyone's attention. SD-WAN is a technology that simplifies traffic management over a wide area network. How does it do it, you may ask? Well, it uses intelligent software-based controls to optimize routing across all sorts of connection types. SD-WAN is also totally independent of any telecommunications provider's infrastructure. So, what does this mean in terms of benefits? With SD-WAN, you get improved visibility through a single point of management, meaning no more worries about network complexity. You can prioritize the most important activity and allocate bandwidth where it's needed the most, which means better availability, reliability, and performance compared to MPLS. And there's more. Deployment and configuration of SD-WAN is a breeze compared to other options, plus its ability to work with multiple connectivity types makes it hugely helpful for today's dynamic and distributed enterprises. Flexibility and scalability are no longer an issue. So, whether you're a large company with sites all over the place or a growing business with big dreams, SD-WAN is ready to support your network needs. However, we all know that our digital world moves at lightning speed, so unsurprisingly, it didn't take long for our demands to change. We needed an inventive network solution to keep up with our fast-paced technical world, and not that we knew it at the time, it needed to be adaptable to allow for our new flexible ways of working. And in 2019, it arrived in the form of SASE, Secure Access Service Edge. Even industry leader Gartner described it as a new thing after SD-WAN in their 2019 report. So, what's so special about SASE? Well, it's an exciting evolution of SD-WAN that builds on its core magic to give us optimized performance right at the network edge. But perhaps even more crucially for today's world is that SASE takes security seriously. It's got integrated enhanced security tools designed to tackle our current and future cybersecurity concerns. SASE does this all via the cloud, delivered right at the network edge. So no matter where you are, whether you're out on site or in a coffee shop down the block, you get the same top-notch performance and security as if you were sitting in your company's central location. With all the fantastic innovation of SASE, you might be wondering where this leaves SD-WAN solutions. Well, despite some pandemic-related delays and the rise of SASE, the SD-WAN market has held strong. In fact, it's been steadily growing thanks to sky-high demand for cloud solutions and SD-WAN as a service. We're also likely to see SD-WAN offering a helping hand in the widespread adoption of wireless WAN, extending its performance and availability benefits to enhance cellular and satellite connections. However, SD-WAN alone still leaves the security issue unaddressed, and you may not be ready for the SASE journey yet, but there is a way around this challenge. Choose a managed SD-WAN and security can be built into your solution. So whether it is managed SASE or managed SD-WAN, whichever is right for you, it is all about ensuring that your network is optimized to deal with today's challenges and flexible to evolve as the digital landscape continues to change. The next podcast, What is Wireless WAN and How Can It Be Advantageous for Your Business, will be out next Thursday. Do subscribe or follow me on your podcast platform of choice to be notified when it comes out. Thank you for listening and do enjoy the rest of your day.